So now we're going to start with a concept that we call as sorting. Now, when I'm talking about sorting specifically, it is nothing. It is arranging things in a particular order. Okay. So supposingly your teacher asks you in an exam or in your practical viva that what is sorting? It is arranging something in a particular order. We call it as your sorting. Now, when I'm talking about sorting can be in ascending order, that is smaller to bigger, or it can be in descending order, from bigger to smaller, right? Yeah, bigger to smaller, and this goes smaller to bigger. Yeah. Now, in sorting, we have certain types. Now, I'm going to talk about a specific type, that is our bubble sort. Okay. The bubble sort does what is, it arranges the data or arranges your characters into a sorted way, of course, in a particular order, but in your ascending order, that is smaller to larger. So if I have my n amount of elements, that is my 6. So it will go my n minus 1 iterations. So the steps are, first step is in your bubble sort is, it will have n minus 1 loop. It will run n minus 1 loop or n minus 1 iteration. Okay. The second step that goes it, the adjacent items are compared. Because if my first item is larger than my second item, then they of course swap the position. Compared. The third thing that happens is you always push the large elements at the end. Yeah. So this is what bubble sort is basically about. So we talked about the n minus 1 iteration. So if I have my 5 elements, then it will run 4 times. Okay. And each loop is denoted by I. So I, and I. I start from 0, I is equals to 0, I is equals to 1, I is equals to 2, and I is equals to 3. When my I is 0, in that condition, the loop will run 4 times. My I is 1, my loop will run 3 times. My I is 2, in that condition, my loop will run 2 times. And my I is 3, in that condition, my loop will run 1 time. There's a specific order. Each time the loop runs, it does arrange it in an ascending order in the adjacent element to further reach the final ascending order kind of output. So when I need to apply this into my coding, how are we going to do? Let's see that, right? So let's just code it. Yeah. So um, there we go. Hash include h. Then we have our int name. Return 0 is a mass. Yep, there it is. Now we need to take I, right? Supposing let me consider an array first. Int a, and my unsorted list holds like let's take an example, 5, 2, 3, 1, 4. Yeah. So we're taking this as an example of our unsorted list, unsorted array. And we take int I, j, yeah, n is equals to 1, 2, 3, 4, 5 because there are 5 elements. And then we're going to say C is equals to 0. C is a counter that we'll be using to swap the elements. Now, coming to the code, we say for I is equals to 0, comma, I is less than n minus 1, n minus 1 because n minus 1 iterations or loop is going to be run, and the number of time the loop is going to be run is our I, right? So I plus plus increment. Then comes a j. J is the number of comparisons in our loop. So for j is equals to 0, comma, j less than n minus I minus 1. Now, in case some of you don't understand that concept, in this concept, what is happening is that when my I is equals to 0, right? The number of comparisons is 4, right? Now, how can I say it? Can I say it n minus I minus 1? So here my n is my 5, minus I, that is my 0, minus 1, that is my 1. So 4. When my I is equals to my 1, the number of comparisons becomes 3. So n minus I minus 1. So 5 minus 1 minus 1. So it becomes 3. So j is the number of comparisons and we take it like that, right? Comma j plus plus. Now we say if a j. Now here j is particularly referring to the index. It is pointing out to the index. So if my index, that is j, that j is 0, it starts with 0, is greater than your a, j plus 1. So 0 plus 1 is 1. So if the index, first index, is greater than the second index, then of course we will swap the possessions, right? In that condition, what we're going to do is, certain times people use void in those conditions, but why should we complicate the things using swap and void if we can just use a normal variable which can store the values temporarily and we can print the sorted data more easily. This is the easier version which I'm telling you. We are taking C, that is 0, of course. So C will hold the value of array j plus 1 values. Why? Because j plus 1 was less than the aj. Okay. Now, if this aj plus 1 array aj plus 1 is empty, now we're going to say aj plus 1 becomes, what does it become? Which values is it holding now? It holds the value of j now. Okay. Right. Yeah. Um, yeah, yes. Now my AJ is empty, so I say my AJ. Why did I took A? No, I took A. I took A, right? Now my AJ becomes my C. So what is happening is that the value of this element, which was less, gets stored into C, a temporary element. Okay, wait. Yeah. So the value of my aj plus 1 that was less than it gets stored into my temporary element, and then the value of my temporary element that is now empty. So it holds the value of my element that was larger than it. and the number that was larger holds the value of the earlier element which was less than it. So it can be arranged into a sorted manner, right? Now, next up, we're going to say printf sorted array is okay. And we're going to go for I is equals to 0, comma I less than n minus 1, comma I plus, and then we are going to go with printf %t, comma a I. So we're going to get or list printed successfully. Let's just see if I forgot to add interminators in my loops. Let's see. This is the output sort correctly, and so this is it. This was all about your bubble sort. Thank you so much.